Welcome to Brain Vision.
Right, in this question we are given a table of data that describes the motion of a baseball through the air in a projectile motion. So we're going to start off by calculating what is the work done by the air, right, in terms of air resistance as the baseball travels from its initial position from the ground all the way to the top. Now we know the top is where the y velocity is 0. It is when it stops moving higher. So what we want to compare is the initial total energy and the final total energy. So the total initial energy is just kinetic energy, right? Basically half mv square. So we have two different directions, so we have two kinetic energies. So half m we have in the x direction, that is 30 square. We have also in the y direction, which is 40. Now we know the baseball has mass of 0.145, so we take 0.145 divided by 2 multiplied by this expression. So this is the total initial energy. Well, the total final energy in this case is we still have kinetic energy in the x direction, but the y direction has been converted into potential energy, right? Gravitational potential energy, which in this case is dependent on the height. And we are given that the height it reaches is 53.6 meters. So we take mg times 53.6 meters. Well, at this height, the velocity in the x direction has decreased to just 18.6, right? So we're gonna use 18.6 square. Now, after calculating everything, we should get a value of 101.3 joules, around there. And so it tells us that the work done by the air on the baseball must be equals to final energy minus the initial energy, which gives us negative 79.9, which is about negative 80 joules. Now we're going to do the same thing, but now our starting point is at the top, right? And we want to find out what's the difference when it is at the bottom, when it reaches back to the initial elevation. So energy, final energy number 2, right? The second final energy, when it's at the bottom, we have no more elevation, so no more gravitational potential energy. All of it is just kinetic energy. So half m v square, where we have velocity from the x direction to be 11.9, and velocity in the y direction is 28.7. This gives us 69.98 joules. again, we find work done by the air. We take the second final energy minus the first final energy. Get about negative 31.3 joules. And we see that this is a smaller work done than the initial work done, which is 80 joules. Right, and the reason is because the ball is moving slower on its way down, and we can see that with the velocity in the x direction. Right, the velocity when it's moving in the x direction actually slows down, even though it's not affected by gravity. And so because our x component of the velocity has slowed down, the overall velocity must have decreased as well. And as such, we know that since the air resistance is dependent on how fast you are going, so when the velocity is lower, the force of the air resistance will be lower, and hence the work done would decrease, will be smaller in magnitude.